Hello and welcome again. We're going to take a look at balancing something called redox equations. And these particular equations are going to seem a little bit different than what you've seen before. What I mean by that is we're going to all of a sudden be pulling water and acid and base particles into play to balance these equations. So first I'll list some of the points about how to balance these equations, and then we'll apply them to an example. The first thing you'll notice is that we're going to balance this equation in an acidic solution. That means that we can grab water molecules or acid particles to help balance the equation. To begin with, I'm going to determine the oxidation states of all the species involved, and I've listed them here above each of the elements. We can see that the chlorine has gained electrons, so it's undergone reduction. And the iodine, on the other hand, has lost electrons and undergone oxidation. I'm now going to divide this reaction into what are called two half reactions. One of these reactions will be oxidation, the other reduction. Now, I begin by balancing the first equation by adding a water molecule to balance the oxygens that are present. Then I balance the hydrogens by the addition of the acid particle, H+. I'm now going to determine the charge on both sides of the equation. So the total charge on the reactant side comes out to +5. The total charge on the product side is -1. I can now add electrons to balance this half reaction. Electrons being negatively charged can only bring the total charge down. So I always go to the side that has the highest charge, and in this case I'm going to add 6 electrons to bring it down to -1. This represents a reduction reaction. I'll now move down to the iodine. The first thing I need to do is balance everything other than hydrogen and oxygen. So I'm going to put a 2 in front of the iodine. Now we'll balance the oxygens by adding 6 water molecules and the hydrogens by adding 12 acid particles. Again, I'll determine the charge on both the product and the reactant side. The products have a charge of +10. They're the higher of the two, so to bring it down, I'm going to add 10 electrons to that side. I'm now approaching step number 6, where I want to balance the number of electrons lost and gained. And in this case, the easiest multiple is 30 electrons. So I'm going to multiply the first equation by 5 and the second equation by 3. That will ensure that the number of electrons lost and gained are equal. Now, let's expand each of those equations by multiplying by the factor that I identified. And now we're in a step where we can add these two equations together. I'll do a little simplifying before I put them together. The first thing I notice is the 30 electrons on product and reactant side can be reduced. The 36 hydrogens on the one side can be reduced with the 30 on the other side down to 6. And similarly, the water, the 18 and 15, can be reduced down to 3 water molecules. I'm now in a position where I can add these two equations together to get the overall reaction. It's useful at this point in time to verify that the equation is balanced. So identifying both the number and types of atoms on both sides ensure that they're equal. But equally important is check that the charge on both sides is also balanced. In this case, the reactant side has a total charge of -5, and the product side also a total charge of -5. Let's take a look at a second example. Again, I'll identify the oxidation states of the elements and identify the two half reactions that are taking place. I begin the first equation by balancing everything other than hydrogen and oxygen, so I need 2 silvers. I'll bring a water molecule into play to balance the oxygens and 2 acid particles to balance the hydrogens. Check the charge. The +2, I need to give that side 2 electrons to bring it down to 0. And now we're set to take a look at the second equation. And this one will balance pretty easily since it only has the 1 element iron involved. And we don't need to add hydrogens or oxygens to this. We can go directly to adding electrons. I can see from this equation I'm going to need to multiply this one by 2 to balance the electrons lost and gained. Now we're in a position to add these two together. And again, we can do a little simplifying beforehand by removing the electrons. And now I've arrived at an overall balanced equation. Again, check the number and type of atoms as well as the total charge. On the left-hand side, the total charge is plus 6, and on the right-hand side, total charge is plus 6. Now, we can also balance solutions in basic solutions. To do that, we repeat the steps that we used for balancing in an acid, and then we add 3 more steps. So, let's take this equation and balance it first of all in an acid solution. Again, I identify the oxidation states of all the elements and identify the changes. So, what's a little bit different about this one is there's no corresponding substance for oxygen to match on the other side. At least it doesn't look like it. But remember that this solution takes place in an aqueous solution where we've got water molecules and hydrogen particles and acid and base particles. So see how I handle that. So there's the first half reaction. And the second half reaction I'm going to leave a little bit blank at this point. Let's go back and balance the first one. I have to add 2 to balance the sulfurs. Then I have to balance the oxygens by adding the 4 water molecules and the 8 acid particles. The total charge on the left-hand side is -2, and the total charge on the right-hand side +4. I give the right-hand side 6 electrons to make it equal to the -2. Now, let's take a look at how we balance the oxygens. Again, I can just add water molecules to start the process off, producing 2 water molecules to balance the oxygens. Then bring in the acid particle to balance the hydrogens, and lastly the electrons to balance the charge. Again, I'm looking for a common multiple here, which would be 12 in this case. So I'm going to multiply the top equation by 2 and the bottom by 3. Expanding those equations, I get the following. And we can do a little simplifying beforehand. Again, the electrons should cancel. And I can simplify my waters a little bit. And I can simplify also my acid particles. Now we're at the situation where we're going to introduce steps 2 through 4. What I notice is the presence of 4 acid particles on the right-hand side. That means I'm going to need to add 4 base particles to both sides of the equation, shown here in red. Now, the acid particle and the base particle can combine to make a water molecule. So in this case, 4 water molecules will take their place. Now I can cancel out the water molecules on both sides of the equation and simplify them. And now I've reached a balanced chemical equation in a basic solution. So it's just a slight modification from that used if it was an acid.